We're very excited for today's webinar that will be presented by Dan Griffiths of Parsons and Kavitha Dasu of Battelle on a technology-driven approach to better PFAS investigations. You can advance to the next slide, please. So just a few housekeeping items up front. We will be keeping all phone lines muted during the presentation until the end when we have Q&A. If you have any questions throughout the presentation, you are welcome to submit them into the chat box and we will answer them during the Q&A at the end. This webinar today has been approved for 1 PDH credit. If you would like to get a certificate for that, you can download and complete the attendance form that is in the chat session. If you're an external attendee, you may not be able to access that, and please send us an email and we will send that to you. There are 4 multiple choice questions in order to get attendance, so just keep that in mind as you're watching. And this webinar today is being recorded and will be posted on our YouTube channel in several days for future reference. Next slide, please. So today's agenda, we'll briefly introduce the 2 speakers, go over a core value moment before getting into the presentation, and then wrapping up with Q&A. Next slide. So Dan Griffiths is Parsons Pfos Practice Director and Subject Matter Director for Groundwater Restoration. He has over 25 years of experience specializing in complex environmental site investigations and remediation. He's also a registered geologist and a Parsons Fellow. Kavitha is Battelle's PFAS lead chemist and has 13 years of PFAS research experience. She's currently the principal investigator for Battelle's PFAS signature and total organofluorine method. She's also a member of the Battelle Technical Council. And with that, I'll turn it over to Dan.
All right, thanks, Jess, and thanks everybody for joining. I know it's hard to find an hour in the middle of a Wednesday, so I very much appreciate your time and your attention for this presentation. I'm also very proud to be here to present this collaboration between Parsons and Battelle. We've been collaborating on various projects for industrial and federal clients for at least the last 20 years, as far as I've been directly aware of, and I'm really proud to be involved in the next step in our collaboration. I wanted to start this presentation with a core value moment. For our regulators, I'm sure you've seen this slide before. Parsons has 6 core values that we use to guide our decision-making processes and really our business. Those core values are safety, quality, integrity, diversity, innovation, and sustainability. And I thought appropriately, considering we're talking about a technology-based way to deliver a better PFAS investigation, that I should focus on innovation. But before I get into the core value, I also wanted to give Kavitha an opportunity to talk about Battelle's mission and their core values. Kavitha, can you present the slide?
Yeah, thanks, Dan. Good afternoon, everyone. I'm glad to be here presenting about our technologies and our collaborations with Parsons. So the Battelle has been over 90 years of innovation. Battelle is a nonprofit charitable trust formed in 1925 from the will of our founder, Gordon Battelle. Our mission is to translate scientific discovery and technology advances into societal benefits. So pretty much the profits are reinvested into research and development, STEM education, and some of the charitable causes. Mainly, our business focuses on national security, health, environment and infrastructure, and lab management. Battelle manages around 9 national laboratories across the country. Over to you, Dan.
Thank you. So there are a lot of alignments between Parsons and Battelle in terms of how we run our businesses, what we're focused on, and really innovation and sustainability and giving back to the world that we live in are really our core values. In terms of Battelle's efforts, we have the Battelle conference that's every 2 years for chlorinated solvents. There's also the sediments conference that runs opposite. It's really an excellent opportunity for world leaders to come together and talk about the contaminants that we face and how to address and remediate those contaminants. Battelle also has a number of first of their kind sites and remedies that they've designed and implemented, as does Parsons. And both organizations have a series of technologies that we've developed that are available on the market, ways to do better things, to implement better strategies for remediation. And some of the things that you see in the middle are examples of patented and non-patented technologies that both organizations have brought forward. And on the right-hand side of the slide are just a list of recent innovative projects that have been completed. The first one, the Kentucky Superfund site, is a project that Parsons and Battelle are collaborating on right now. It's a large project wherein we're both bringing our technical capabilities together to develop a better solution for the client and for the community around that site. And then you see a series of other projects that we've delivered over the last few years. A number of these projects are not remediation projects. The National Environmental or National Energy Technology Laboratory and the National Ignition Facility are two facilities that we operate for the federal government to deliver better solutions and innovation technology development for the world as a whole. And another great example is the Dubai Metro Red and Green Line. That's actually a transportation project, but it's a great example of bringing together technology and innovation to deliver a better product to the client and to the people that use those rail lines. So there's a lot of parallels and a lot of collaboration between Parsons and Battelle and how we do our business and how we bring innovation and technology to the world to the betterment of our clients and the people that live around our sites. Okay, so a brief overview for the presentation. This presentation really is focused on how to deliver a better PFAS investigation. There are a number of processes and tools that we'll present. All of them don't have to be applied to every site. It is very much an a la carte type of menu wherein a particular site can pick and choose the tools and technologies that best fit that site. Not all are required for a particular site. I'll talk a little bit first about how to start, where to start in your PFAS investigation. It really starts with the data review and the dynamic work planning process. And then I'll talk about some of the field-based decision-making processes that we utilize and the tools that we use to actualize real-time decision-making. And some of the values of those tools, like electronic data collection and real-time QA that comes with that data collection, as well as passive samplers and some of the great tools that Battelle brings to the mix. And then Kavita and I will talk about proportional analysis and fingerprinting as advanced data analysis methodologies to bring more value to the data set that's being collected in the field and ultimately to produce a better investigation result at the end. And I'll wrap up with some communication and team decision-making tools that help us communicate the decisions we're making, the data sets that we're creating in real time during the investigation itself, and then ultimately at the endpoint. Okay, so a PFAS investigation approach really starts with making the best use of the data that you have. It's developing a flexible work plan that's focused on your investigation objectives first, and then adding the tools and the methodologies that you need to actualize the achievement of your investigation goals. There are several key components to an optimized investigation. The first is really to do your homework, plan ahead, and develop a flexible investigation plan that allows your field team to utilize the data as they collect it to the best of their ability and to make decisions within the work plan framework to continuously adjust sampling points as they're collected today based upon the data that you collected yesterday. To support this process, your work plan may consist of a series of defined starting points, like redeveloping and sampling existing wells, and then a series of decision trees that allow you to define how decisions will be made based upon the data you collect. Gone are the days where a work plan consists of a series of maps with fixed dots and a table of of fixed samples that you're going to collect, and then iteratively working through work plan after work plan to ultimately meet your investigation objectives, perhaps years down the road. A flexible work plan allows you to achieve your objectives typically within one mobilization and to bring to your client a much higher value, much higher quality data set at the end. And some of the tools that you see on this slide, I'll talk about in more detail in terms of digital data collection, online dashboards, which is really a communication tool more than an analysis tool. Three-dimensional site conceptual models down in the lower right, one of our favorite tools to use in the planning phase as well as the investigation decision-making phase. And then the field data analysis up on the upper right. This happens to be a proportional analysis tool that I'll talk about in more detail, in addition to the Pfos fingerprinting tool that Kavita will talk about. I mentioned on the previous slide that the first step in a good Pfos investigation is really to do your homework and use the tools you already have. In many cases for Pfos investigations, we are investigating sites that have already been assessed for other contaminants, perhaps petroleum or chlorinated solvent contaminants. So there are already wells in place, there's already a data set or a series of data sets in place that you can utilize to develop a framework for your Pfos investigation. You would be amazed at how many sites I walk onto where the previous consultant or the previous investigation contractor attempted to reinvent the wheel, collected all new data to define stratigraphy and hydrogeology and geochemistry when that data was already present, and would have been far more efficient to have just drawn that data out of previous reports or previous databases and incorporated it into an overall site understanding before the contractor ever steps on site. The picture to the right of this slide is a great example of a fire training area that Parsons investigated within the last couple of years. There was already a series of investigations that had been conducted. There were a series of monitoring wells that had already been in place. And the first step to this investigation was to go out and assess the condition of those monitoring wells to ensure that there were still good advocate monitoring wells, and then redevelop specific wells for resampling, so that data could be collected very rapidly and at relatively low cost as a starting point to this particular investigation. Now at the site, this comes directly from the site we were just talking about on the previous slide. There was sufficient information available to develop a site conceptual model. The graphic to the right-hand side of this slide is our example of a three-dimensional model that we were able to create using existing boring logs, existing well installation details, so that we could develop a better understanding of site stratigraphy before we ever stepped on site to execute our Pfos investigation. And this is very typical for a site that's already been investigated. It may just take a little bit of investigating and sleuthing to dig the details out of the previous reports. Ideally, boring logs are present and the data can be compiled very quickly and easily into a three-dimensional site model that can be used as a starting point for your investigation to guide decisions moving forward. The beauty of a three-dimensional site conceptual model is you build it at the starting point, and then you're able to update that three-dimensional site conceptual model as you collect more information, perhaps more boring logs, more contaminant information from groundwater, as well as other matrices like soil or surface water that allow you to update this site conceptual model on the fly, and can be used as a communications tool as well as a tool to better understand site dynamics and make better decisions in the field. All right. And flexible work plans really are critical to maximizing value. We use this approach very commonly for Pfos investigations as well as other contaminant investigations, where we start with a series of predefined starting points, perhaps your pre-existing wells. We resample them, and then you use that data to advance within your decision-making framework in your work plan. Also valuable for Pfos investigations in particular are a short turnaround time lab analyses, or if you have sufficient sample quantity, mobile lab analyses. so that you can be generating data in near real time and updating your site conceptual model so that you can make better decisions in the field. We also use these models to hold investigation meetings during the course of the investigation with our clients, as well as regulatory agencies, so that we can keep the team updated as we move forward and make sure that everybody is buying into the data set we're collecting and the decisions we're making, with the ultimate objective being the development and production of a higher quality data set that everybody has buy-in into, and we exit the field ultimately with a data set that everybody supports, which means that your reporting processes are far more efficient and your report approval is far more rapid. And at this point, I would like to transition over to Kavita so that she can talk about some of the passive samplers that Battelle brings to the investigation story. Kavita, it's all yours.
Thanks, Dan. So I'll be talking about the Pfas passive sampler. This is a sampling tool which measures the freely dissolved or bioavailable fraction of the contaminant. So it has been traditionally used for long-term site assessments. But the main challenge with the PFAS that comes is having a high potential for cross-contamination and some of the Teflon background which might be present. Of course, we have been working through these challenges, and now we have a better handle of to deal with it. But increasing analytical cost becomes another real challenge for when we are doing these very broad site investigations stuff, where we need to collect more number of grab samples to get the real understanding of the site. But having these passive samplers which could do a time integrated representative concentrations, which could provide, would be really valuable for doing these long-term assessments. And another advantage to that would be when we are doing, for example, there is a big storm here at Columbus. After this storm, if you go and collect, there will be a very high spike in concentrations, either in the surface water, most pretty much. So having to collect or get a really good understanding of average concentrations at either surface water or groundwater, having this passive sampler really provides a very good time integrated average concentration at a particular location. So having the PFAS, understanding the unique properties of the PFAS, high water solubility, and its surfactant properties, it is really difficult to use some of the conventional passive samplers because it becomes very difficult to apply the same samplers for the passive samplers because of these properties. So Battelle has developed the Pfas Insight, which is a passive sampler, and it's a equilibrium regimen sampler, which could be used for surface water, groundwater, and also the pore water to measure PFAS. So far, we have done 3 different field demonstrations of these samplers to measure the PFAS concentrations in both groundwater and the surface water samples. And the samplers, as you could see on the figures here, but on the plot shows actually how representative are these PFAS concentrations measured using the passive samplers and the grab samplers. Pretty much most of the surface water locations have shown very good representation of the concentrations which were measured using the grab samples, but there were, and most of the groundwater monitoring wells also showed the very good overlap with the groundwater concentrations. Overall, besides this easy, freely dissolved fraction of the PFAS which could be measured, which is really applicable to understand the bioavailable fraction of the PFAS, and which could be used for some of the risk assessments as well. But having this time integrated results really helps eliminate some of these short-term temporal concentration changes and helps for the better long-term site assessments. Next slide, Dan. And this is a PFAS ambient air sampling tool. We call it as a PFAS Insight. Pretty much as we know that PFAS are widely used for many different applications, or at a commercial manufacturing sites, or some of the wastewater treatment plants where the aeration process is going, and nearby some of the incineration facilities. There is a real concern of what if the PFAS are present. Some of these volatile PFAS might be airborne and they might be present. So this tool provides a unique tool when doing some of the investigations. For example, a remediation site having a remediation, some of the technologies which are used for these remediations might be creating some of these volatile PFAS emissions in the air. So this tool application comes into the picture of measuring some of the airborne PFAS which are there, and also some of the particle-bound PFAS. Some of these ionics might be bound to the particles, and that might be present and airborne. So the passive sample, the air Insight sampler is developed as a modification of the EPA method TO13A, which is a high volume air sampler using Puff XAD Puff and quartz fiber filter media, where we measure both the ionic PFAS as shown on the table on the right side. Some of the ionic PFAS, 24 PFAS ionic are present, and also some of the neutral PFAS, with neutral and semi-volatile PFAS, which are measured using the GCAMS analysis. And the sampler has been field demonstrated. We have done a PFAS incineration study where the ambient Pfas, which are present in the upwind and the downwind of a full-scale sewage sludge incinerator. And we have seen really good capture of some of the volatiles which were present at that site. Next slide, please. So this total organofluorine method, which, as we all know, that there are only very few PFAS, targeted PFAS out there, which has analytical standards and we could measure. But there are so many other PFAS which might be present, and we don't have the standards for them. So measuring this overall total fluorine, organofluorine content present in the sample becomes really important. And so the Battelle have developed some of this novel screening tool, which could be actually applied as a quick and dirty method for some of the site investigations, where we could understand the total PFAS to organofluorine content present at a site. Or it could also be done as some of the background, understanding the background PFAS concentrations at while doing a site investigation. So this method is actually measures the free fluoride, which is generated using by a quick reductive defluorination method, and the analytical tool which is used is usually ion selective electrode if it is a pretty quick, or otherwise we could use the ion chromatography method as well. And as you could see, the plot on the top right corner, it shows the results of the top for the 2AFFF. The bottom blue portion actually shows how much you could measure using your typical LC-MS analysis, whereas the top orange portion shows you the total organofluorine content measured using this method. And as you could see, there is so much of unmeasurable PFAS content which might be present in a sample. And so that's how this method could be used for some of the site investigations, which could be very quickly. You could do this instead of the very elaborate LC-MS methods, and still get the data about the total fluorine content. The method has been demonstrated on some of the aqueous, solid, and the AFFF matrices, so it's applicable for different matrices as well. Next slide, please. So now, yeah, I would transition to Dan to talk about the electronic data collection and real-time QC.
All right, thanks, Kavita. So I'd like to spend the next few slides to talk about some of the tools that we use to bring better data value to a PFAS investigation. The first, of course, is electronic data collection. This is a tool that we've been using for some time. It's particularly applicable to PFAS investigations, and it really allows us to rapidly characterize an investigation site and to make field-based decisions as we move forward. All of our field records and observations are collected using electronic data tablets in the field. And this is particularly useful for, say, groundwater sampling and for collecting, surface water sampling observations. In that, for a electronic data collection methodology, your tablet computers are directly linked to a database back in the office. And as as your field technician enters data points in the tablet computer, those data points are compared to perhaps historic values from a groundwater monitoring well or a surface water body. And if the results differ significantly, the tablet computer will give the technician an alert to check and ensure that the instrumentation is properly calibrated and that the data value is real. And real-time data collection using these electronic tools allows for real-time QA, which I just talked about in terms of an error checking process, as well as elimination of transcribing field notes from a notebook or a series of hard copy forms at the end of the day into an Excel file, which accelerates the usability of that data and also eliminates transcription errors as well. This is a great tool to use for a Triad-based active field-based decision-making investigation because it allows you to utilize that data right away rather than waiting, and also eliminates those potential errors. And here we have an example of a field form to support the collection of groundwater samples. This was highlighted on the previous slide. A little bit more detail on this slide. Note that the groundwater stability data that's being collected in adherence to EPA low-flow sampling protocols is right on the field form, and the field tablet computer calculates stability automatically given the parameters that were input into the field tablet computer, so that the technician doesn't have to be sitting on a bucket with a calculator to determine stability. The system does it for them. Also, that real-time error checking comes into play here, such that the data that's being collected is of the highest quality. There's a repeatable and checkable arrival at stability for this particular monitoring well or the monitoring well being sampled, such that the data that's being collected is of much higher value. Gone are the days where you see DO reported in the 10 or 20 milligram per liter range, which is of course beyond saturation, because we have automatic error correction and detection within our field tablet computers. The forms can be modified and can be customized for any site, any parameters of interest. This is just an example that we used commonly. And also note that the tools that I'm talking about, the Forms on Fire tablet computers, none of them are Parsons tools. They're all modified tools that are on the market, free for use. So there's nothing Parsons specific here, and no reason why you can't use the same tools on your site as well, really starting today. And here's a great example of an electronic boring log. Again, this is on a field tablet computer, and the geologist is filling out this log as the boring is being drilled. So in terms of depths of stratigraphy changes, soil descriptions, USCS classes, everything from field meter readings, screening meter readings can be collected on these electronic field forms. And then the field form is uploaded directly to a database, when the boring is completed and concluded. And this data can be incorporated immediately and directly into a three-dimensional site model, like the one I showed earlier in this presentation, and utilized immediately to update and modify that site conceptual model, and the project team's understanding of site stratigraphy, visual observations of potential impacts, VOC readings from headspace, so that this data can be utilized immediately to make better decisions in the field and to bring more value to the investigation data set. It isn't just a tool to improve our understanding of stratigraphy, it's also a tool that can be used to understand hydrogeology, potential high flow zones within that boring log, as well as potential impacts related to visual observations as well as field meter observations. Oh, sorry. Okay. So the last tool I wanted to talk about is it's a decision-making tool in terms of the 3D CSMs you see down on the right-hand corner of the slide, but it's also a communications tool. And I show an example of an online dashboard in the upper right corner of this slide. All these tools are useful for internal team understanding and decision-making, but they're also highly useful for communicating the information as you're collecting it, the data as you're collecting it, and you're improving understanding of the site conceptual model to your client team as well as to your regulators. In the ideal world, Triad-based meetings or Triad-style meetings are held frequently during site investigation when the field crews are still in the field, so that data can be shared, improved understanding can be shared, and decisions can be made on a team basis with involvement from your regulatory agency personnel, such that the entire team is involved, the entire team takes ownership in the data set that you're creating, the decisions you're making, and ultimately you leave the field with a very high quality, very high value data set that meets all of your objectives because your entire team has been on board throughout, and ultimately results in better decisions in terms of remedial path forward, as well as more approvable reporting documents. And all of these tools are also highly valuable for communicating your findings, your decisions, and your path forward to other interested parties like the public. There's nothing like a graphical presentation for a public audience to drive your points and to communicate pretty complex processes to the general public. It's really difficult to explain a complex site using potentiometric surface maps and 2D, plume contour maps. A three-dimensional figure is far more valuable. It's something you can put on the screen, turn around, turn upside down, look at from the bottom to really communicate your understanding of the site to your audience. Okay, and for the last segment of the presentation, we're going to talk about some real-time data analysis tools that can be used in the field during an investigation, as well as some very advanced investigation approaches that Battelle is bringing to the better PFAS investigation concept. So the first tool I wanted to talk about is called proportional analysis. It's really the analysis of the proportions of PFAS molecules within a particular PFAS data set at each sample location. The radar plot on the right-hand side of this slide is a graphical representation of the distribution of PFAS within a sample result. So in this case, you have a lot of PFOS, a lot of PFHXS, and lower concentrations of PFOA and PFXA, as indicated by the blue spikes within that radar plot. And this is a basic analysis method that allows you to draw more value from your PFAS data set. It allows you to, in the field during your investigation, develop a better understanding of potential source type and potential contaminant mass flow pathways. This, in conjunction with the rest of your data sets, your stratigraphy, hydrogeology, contaminant concentrations, geochemistry, and understanding of matrix interactions, really allows you to build a line of evidence-based understanding of your site as you execute your investigation. There's no need to wait until the reporting phase to do this analysis, because it is very simple. It's a Excel-based analysis of your PFAS data set in conjunction with the remainder of your lines of evidence to build a better picture of your site as you execute your investigation. It's a great, quick and dirty way to bring better value to your data set as you're moving in the field through your investigation phase. And just a little more detail on how this proportional analysis stuff works. I'll take a little bit of time to explain how we organize our radar charts. This is the same radar chart that you looked at previously. It's just highlighted to identify the different types of PFAS that we typically see in a PFAS analysis. And as you can see, broken out in the various colors here, we've arranged the chart first by PFAS type. And in the top, in the purple, you see we have per fluorosulfonates such as PFOS, PFHXS, with PFOS in the 12 o'clock spot, because that's one of our most common PFAS molecules that we detect. And in the bottom in the green, we have perfluorocarboxylates such as PFOA, PFNA. And in the top in blue, we have the fluorotelomere sulfonates. So they're divided by family. And then in the clockwise direction around the clock face, we have each of the PFAS types organized by carbon chain length. You see the numbers in red. PFOS is C8, PFHPS is C7, and on down the line through each of the families. So it brings a little bit of rhyme and a little bit of reason to how these are organized. And it's really important for you to just pick a consistent methodology. This happens to be the one that we use commonly to organize our data sets, but there's no reason why you couldn't use a different methodology. It's just really a graphical means for you to organize your PFAS data sets so that you can visually identify changes in proportion, which is an indication of change in potential source type or a change in transport pathway. Just an example that I'll walk you through of PFAS proportional analysis that was performed at a fire training area where legacy AFFF was used during training. There are 4 different radar charts on the plot, as you can see. The closest to the source area on the left, and then moving down gradient progressively to the right. The PFAS radar diagram for the sample from the well closest to the fire training area, which is MW1. Shows a signature that we'd expect from a PFAS release from previous AFFF use at the fire training area, has strong relative PFOS signal compared to other PFAS, and also shows PFOS at a very high concentration. These radar diagrams show both relative proportions of the PFAS compounds as well as absolute concentrations, so concentrations by the height of the spike. And PFOS at the first well is at a concentration of about 14,000 nanograms per liter, and then reduces down to about 10,000 nanograms per liter in the next well down gradient. And then as you move further down gradient, the concentration declines 1,600 and then about 20 nanograms per liter in the down gradient most well. You'll also notice that the radar chart signal is changing as you move down gradient. And this is driven by preferential partitioning of particular PFAS molecules as the mass moves down gradient, and the signature changes as you get further and further away from the source area. And the down gradient change in relative percentage of PFAS is also demonstrated in the bar chart in the upper right. And I put this in just to give you another example of how this proportional data can be depicted visually to very quickly assess changes in PFAS proportions as you move further away from the source area, or to identify other source types. You don't have to use the radar charts, bar charts work as well. Right. And here's a great example where we use proportional analysis in the field during investigation just to identify different source types. This is an idealized example of an actual site. So the radar charts you see are real. I've idealized it just to remove any site identifying features to protect our client. But it's a great example where proportional analysis can give you a quick and dirty assessment of your plume and potential sources, and how those potential sources intermingle to create your overall PFAS plume. In this case, in the upper left, we have a radar chart that is indicative of a source type that's a landfill. So you see a strong signature for PFBA, and then some lower concentration signatures for other PFAS molecules, a little bit of PFH excess, a little bit of PFHA, and very indicative of a landfill signature. Over on the upper right, you see a signature that's very typical of AFFF coming from a fire training area. Big spike for PFOS with a smaller spike for PFHXS. And of course, as you move down gradient, that signature is going to change, very similar to the previous slide, where PFOS is still dominant at MW4, a bit further down gradient from the fire training area, but the overall proportion of PFHXS has increased, and you see higher proportions of other constituents like PFOA and PFHXA. And then down in the lower left, you see a signature that is pretty common for AFFF that has been applied in conjunction with high temperature. So this was a plane crash and an AFFF response. And it's you see the high peak for PFOS, but you also see some other constituents in there as well. And this is also a sample that is commingled with the signature from the landfill. So you see mixtures of PFBA, which is typical of a landfill, starting to mix into that radar plot. So a mixed signature and a signature indicative of a mixing plume. All right, and at this point, I'd like to hand this over to Kavita so you can talk about the Battelle Pfas signature tool and your modeling tool. So take it away.
Thanks, Dan. Yeah, so Pfas signature is a high-res mass spec forensic analysis tool to identify Pfas signatures. As Dan has mentioned about some of the proportional analysis, so it is really good to do some of these proportional analysis using the existing data we already collected, using some of the targeted analysis, but to do more definitive or understanding of the source of the contamination, it would be better to have some of the high-res tools, get the data out of the high-res mass spec tools. The reason I'm saying this is, as we all know, that most of the PFAS are, which are used for many different applications, have some different chemistries. But pretty much the end products, if we are seeing, it is all of those carboxylates and sulfonates, which are formed as the terminal products for all of these source specific signatures. So it becomes really difficult to identify some of these sources, but it is really helpful to have some of these proportional analysis tools with the existing data just to start with. So the Pfas signature is a source discrimination tool, which has been developed using some of the high-res mass spec analysis methods. And we have the suspect screening list of around 496 Pfas analytes. So the tool has been developed to focus more on the Pfas analytes looking at, because as you all might know, the high-res mass spec generates a whole lot of data. So it is really difficult to handpick what are the Pfas analytes which are present in that huge amount of data. So We have developed a homolog filtering tool, a PFAS homolog filtering tool, which focuses more on the PFAS analytes so that the filtering which happens, we know that all of the data reduction, we are confident that PFAS analytes, we are picking up all of the PFAS analytes out of that filtering. Followed by the PFAS data filtering, we also use a source library as part of our internal research and development project. We have collected the known source PFAS samples and generated a lot of high-res mass spec data using those known source samples. So now we have developed kind of a PFAS specific source library, which is a high-res mass spec library of these sources. And using that source library, we apply the artificial intelligence and machine learning tools to identify specific or discriminate specific sources which might be present at a site. So this overall, the tool has been developed, and I'll talk more about some of the source specific sources which are present in this source signature library. Next slide, please. So in this database of this source specific signature library, we have more than 14 AFFF formulations which are manufactured from different manufacturers and with different chemistries in each of them. And another scenario where we collected was the samples collected from many different AFFF impacted sites, such as a scenario such as where a wastewater treatment plant was there as a co-located within the Air Force base. So that is the one kind of a different signature which has a mix of both the wastewater treatment plant and also the AFFF signature. Another one is the biosolids applied soils were collected, which also has some of the AFFF signature in them, and AFFF by itself used for some of the emergency responses. In the waste sector, we have collected some of the samples from different landfill leachates and wastewater treatment plants across the country, which had a very different signature based on the influence for these landfill leachates or the wastewater treatment plants. But the type of the source by itself has some of the high-res mass spec signature which was seen. And the paper mill industry, which has its own specific PFAS analytes which are used for the paper coating application. So we have seen the signature of those things in this paper mill specific waste samples which were collected, and the compost, and some of the commercial products such as the pizza boxes or some of the food wrapping paper which has some of these PFAS coatings, some of the carpets, all of those related sources were collected, and the metal plating also. And this library has been, we are continually collecting more samples to populate more of the library and to get more different wide variety of source signatures, because it's so many sources with different signatures, so it's never enough. Next slide, please. So I talked about the high-res mass spec analysis is being done for this PFAS signature tool. So as you could see, when we are doing some of the targeted analysis, all we could get the data is some of these PFAs, alkyl acids, and the sulfonates, right? So it's a pretty limited data we could collect, and based on those, it becomes really difficult to discriminate some of these sources. But using the high-res mass spec analysis, it just opens up the aperture. Like as you could see here, the two samples which were collected from a hangar had a mixed source of AFFF which you could see clearly by some of the fluorotelomere-based precursors and transformation products, and also the ECF-based precursors and their transformation products are seen. And the level of these different analytes, which are precursors, which are present, is also, you'll get the sense of it. But overall, as you could see, we have access to so much more data, which we could not have got from the targeted analysis. And that's the key, actually, for using this high-res mass spec in instrumentation for understanding the signatures of the Pfas sources. Next slide, please. So now we have collected the high-res mass spec data, and we will use some of these machine learning tools to identify or discriminate some of these sources. The plot here is a quick example just to show how different known same source samples cluster together and how we could be able to discriminate those things. Here, AFFF and non-AFFF sources are shown as two different clusters. But if the source has some of the co-located sources, we have seen some of the mixed source samples are also seen as some of them. The plot could be very complex. It clearly gets very complex as a mixed source samples are thrown into it. The clusters will migrate a lot, and you'll see some of those mixed clusters forming in between as well, and depending on the composition of it. So it is a really useful tool, and it helps visualize the data better to understand different source samples and to even delineate some of these distinct Pfas source signatures. Next slide, please. So with all of that information in hand, this tool becomes really handy, but it provides you with so much data that it becomes really overwhelming. But it is a really helpful tool to identify some of the source signatures and to do some of the delineations as well. It's not only that, if we are doing some of these analysis using some of these targeted analysis data, and if you are you wanted to know what's happening, if there is something really difficult to understand from where this signature is changing here, it would be a really good tool to even understand or fill the data gaps like that, to have this high-res mass spec data collected and to see what else is happening here. So, and also understanding the Pfas transport, it helps a lot to see the trends which you are seeing with the different Pfas chemicals, and of course, on-site and off-site migrations. You'll be able to understand if there is a different Pfas signature is seen at a site or off-site. And given this is a high-res mass spec analysis, this whole analysis becomes a qualitative analysis, but there is we could make it a semi-quantitative analysis using some of the known analytes which are present, and do a semi-quantitative analysis. So by doing that, we could also do some of the mass balance evaluations when you're doing some of the remediation type of projects as well. With that, I think we'll go to the next slide on the modeling. Yeah, thanks, Dan. So the Pfas predict is a groundwater transport model. It tracks and simulates the Pfas which might be present and to understand the transport of Pfas in groundwater based on the chemical properties of these Pfas analytes which are present at the site and the site aquifer conditions. And also the source zone parameters. The tool has been developed, has been modified from the Battelle's previous groundwater model, but it applies really well for the Pfas, given the high water solubility and mobility of the Pfas. this unique dispersion process, which the PFAS predict model accounts, is really applicable to understand or predict the fate of the PFAS in groundwater. The model by itself is compatible with the other industry standard ModFlow groundwater models, and this could be used for both the forward and the backward tracking of the PFAS in a plume. And we have used this tool as a desktop tool with the existing data from using a couple of sites. So it has been seen really well working with on predicting some of these fate and transport of the PFAS chemicals at an actual site. So as I mentioned, the tool could be used to simulate the groundwater, not only the groundwater transport to the receptors, but also to perform some of the risk assessments and the remedial design operations. So I think that's all from me, and I'll transition to Dan to provide the overall conclusions.
Thanks, Kavita. So to wrap up this presentation, we gave a lot of information in this deck very briefly and at a high level. So essentially what we're talking about is combining Parsons' investigation approaches, utilizing all of the tools that we talked about with Battelle's investigation toolbox to ultimately bring a much higher quality data set, a much more valuable data set, and a better interpretation of conditions on a particular site to our clients as well as our responsible parties. So with that, I think I'd like to close out the presentation and save our last couple minutes for Q&A. And I think at this point, I'm going to hand it back to Jess.
Thanks, Dan, and thanks, Kavitha, for a great presentation on a lot of great tools for PFAS investigations. I see there's some questions in the chat, but if there's anyone who wants to ask a question live, you can raise your hand and we will unmute you. But starting off with the ones in the chat, from Claudia, what is the cost of the top analysis?
So there is the cost varies based on the matrices. Claudia, I could send you the information of which to understand what matrix you are looking for and the cost for that matrix.
And she also had two follow-up questions. Is there much noise in the top analysis?
So typically when we are using the IC analysis, means ion chromatography methods, I have seen there is a lot of background, which actually the peak, there is a lot of background coming from the acetate or the formate, which might be present using some of these extraction processes. But top, mainly we are using the ion selective electrode probe. So we don't see that much of the background, but as you would have seen on the slide, the quantitation limit is a little bit higher when you're using the ion selective electrode probe compared to the IC methods.
Okay, great. From Akshay Parenki, he asks, how is the reductive defluorination process carried out for top? For example, UV electrochemically, supercritical water oxidation.
This is a kind of a wet lab method, which happens in-house at Battelle laboratory.
One more question from Claudia is, does PFAS predict account for transformation?
It accounts for transformation of some of the known transformation pathways. So it is limited for the known target analytes where we have some data.
And I see Mahir Chokshi has his hand raised. You can go ahead and unmute yourself, please, and ask a question.
Thank you, Jess, and thank you, Dan and Kavita. Great presentation. I wanted to ask in probably a more summarized fashion is combination of Parsons' technical approaches and Battelle's capabilities that we're bringing together. Does this solution expedite field investigation, bring value in terms of, again, cost, schedule, quality, efficiency. If we can kind of give a quick summary on that perspective, what's the value that's going to bring to our clients?
Yeah, I can take that. So we're not talking about accelerating investigations per se. We're really talking about bringing additional value to the data set that we're collecting. We're using tools that are going to bring higher value data and a better understanding of site conditions, potentially offsite sources, pathways of migration to the site conceptual model, so that ultimately when we leave the field with our combined data set, we leave with a data set that has higher value that will help us make better decisions. That's the real value. It's not so much a means to execute an investigation cheaper or quicker. It's really a means to bring higher value to the data set that we're collecting.
Thank you. And Dan, I have a follow-up question, if you don't mind.
Sure.
Can the combined approach be utilized for forensics? We know that PFAS pretty much is everywhere at this point, and sometimes multiple clients have their footprints overlapping or potentially overlapping. Can and how confidently this combined approaches can be utilized for forensics?
Yeah, great question. So you're exactly right. PFAS is essentially ubiquitous in the modern environment. And at any particular, industrialized area, you're going to have multiple sources. I mean, there may be a fire training area, there may be a landfill, there may be a water treatment plant, all of which have different source types and different signatures. And we have the ability to differentiate between major source types and potentially between contribution within a mixed plume. But there is some limitation in that the fingerprinting that we're doing, we're utilizing 400 or so molecules now. There's a total of, I think, 7,000 or more in the PFAS universe. So there is some limitation as to exactly how we can, to what degree we can quantify source contribution to a mixed plume.
Great.
All right, I see we're 2 minutes past our hour. If we can go to the next slide. I don't see any questions in chat. So thank you for everybody for joining us for today's webinar. Next month, on May 11th, we will have a webinar from Julian Chambert on novel in situ remediation of arsenic using nitrate and sulfate. So we really hope you'll join us for that. And this webinar today will be posted on our YouTube channel in the next few days if you want to go back and review anything. With that, thank you to everyone, and we hope to see you again next month.
Right. Thanks, everybody, for your time.
Thanks, everyone.